So right now I should call on Mickey, Dr. Mickey.
Hi, I'm just gonna share my screen if that's all right.
Yes.
And here we go. Well, I'm gonna talk about vocal communication in African Savannah elephants. I actually first started working with elephants, with Asian elephants in Sri Lanka more than 10 years ago. But most of the work that I've done has been with African Savannah elephants in the Samburu population in Kenya that Lucy mentioned. And so I owe a huge debt of gratitude to Save the Elephants, which I collaborated with heavily in the field, as well as, of course, to the national and local Kenyan governments for permission to conduct work in Kenya. So I'm going to first just go through a quick overview of the elephant vocal repertoire, the sounds that elephants make, and then I'll get into some more details about what we know about what those sounds actually mean and how elephants use them. So the sound that most people think of when they think of the sounds elephants make is the trumpet. And it sounds something like this. This is a recording. So you've probably heard that before. That's probably what you think of when you think of the sounds elephants make. But actually, trumpets are not the most common sound that we hear from elephants. Trumpets are basically emotional outbursts that elephants use in highly emotional contexts. So typically we hear this from calves when they're playing, and from adults when they're either really excited about something or really upset about something. So either in the context of disturbance or social excitement. But actually, the more common sound that we hear from elephants, by far the most of the sounds elephants make, are these low frequency calls called rumbles. And rumbles are actually so low pitched that they're partially below the range of human hearing, and they're certainly mostly below the range of what typical speakers can produce. So when I play this sound for you, keep in mind you're actually only hearing a small fraction of the frequencies in this call. Most of them are not coming through the speakers at all. So this would sound a lot louder and different to an elephant than it would sound to us. So this is what the rumble sounds like. It's a very deep rumbling sound, almost like thunder or something like that. And these calls are very complex in structure. So down at the bottom, this band in the spectrogram represents the fundamental frequency, and that's the pitch at which the elephant's vocal cords vibrate. But then there are all these harmonics, which are additional frequencies layered on top of the fundamental. And the sound is filtered through the elephant's vocal tract when they make it. And the shape of the vocal tract determines which frequencies are amplified by the vocal tract and which frequencies are dampened or not amplified. And so these bands of frequencies that are amplified, which you see here is like the brighter bands in the spectrogram, indicated by these white brackets, those are called formants. And it turns out that elephants can actually change the frequencies of the formants by manipulating their vocal tract. So they can produce rumbles through their trunk or through their mouth, which drastically changes the length of the vocal tract and therefore the frequencies at which these formants occur. And then even within a given method of vocal production, they can manipulate the formants more subtly by presumably moving their tongue around in their mouth. And that's actually very similar to how humans produce speech. So when we speak, we move our tongue and our lips around, and that subtly changes the shape of our vocal tract. And that's what we hear as different vowels in human speech. So elephants have these structures in their calls that are similar to human vowels, and that's where a lot of the complexity in these vocalizations comes from. So the next another one of the more common calls that you hear from elephants are roars. Roars are very loud calls, but they're also very diverse. So you can have tonal roars, which sound like this. So tonal roars are like they're a clearer sound. They have very clear harmonics and they sound less noisy. And then chaotic roars are just mostly noise. So elephants can make tonal roars, they can make chaotic roars, And then they can also mix them so they can have roars that are partially tonal and partially chaotic. And roars are also, like trumpets, they're emotional sounds. So most often when we hear these in African Savannah elephants, they're produced by young calves, either when they're begging for milk, like when they're being weaned and they want to suckle and the mother doesn't want to let them. Sometimes we hear a roar, but they're also produced by adults in some contexts. So for female African Savannah elephants, they're most often heard in a sexual context, like when a female is in estrus, but not exclusively. They also make them in other contexts where they're emotionally aroused in some way. There we go. Okay. So barks and cries are both very short vocalizations. So like roars, they span a large range of frequencies, but they're much shorter in duration. Barks are very harsh calls. So they're short, noisy calls, and they're most often made in African Savannah elephants when an elephant is receiving aggression. So they indicate that the elephant is in pain or signaling submission in some way. Whereas cries are something that we only hear from very young African elephants. And this is a call that's more often produced in a begging context. So similar to the context in which a lot of roars are made by. And combination calls are combinations of a broadband call, typically a roar, but sometimes a bark or a cry, with a rumble. So this low frequency harmonic call. And what's interesting about these combination calls is theoretically they could be combined in almost any order. And very occasionally we do see a lot of different orders, but the vast majority of combination calls are one of three orderings: either roar rumble, rumble roar, or rumble roar rumble. Roar rumble roar or other things like that occur sometimes, but they're very rare. So there seem to be these rules for how elephants combine these calls. And roar rumbles in African Savannah elephants are by far the most common of these combination calls. We're not sure about this, but it seems like the ordering of the combination call may affect its meaning. So, for example, rumble roar rumbles are more common than you would expect by chance in the context of separation from the group. But there's still a lot to be learned about exactly why elephants combine calls in this way and what exactly it means. Now, so I want to get a little bit more into rumbles, because rumbles are really the bread and butter of elephant communication. In Amboseli, for example, they comprise more than 90% of the calls recorded from elephants. In some other populations, it's a little bit less, but it's still the vast majority of elephant calls are rumbles. And they can be produced in basically every context, and they also differ acoustically depending on the context in which they're produced, although the variation in the acoustic structure of rumbles seems to be more continuous rather than discrete. So it's not like you can look at a rumble and immediately know all of the time what context that rumble was made in, although sometimes you can. More often it's like this graded continuum of the structure of the rumble varies between different contexts. So one of the most common types of rumbles that you'll hear is contact calls, which Lucy touched on briefly. And these are calls that elephants make when they're separated from social companions at a distance. So maybe, more than 50 meters apart, often considerably more than 50 meters apart. And they use this to communicate with their family members when they're out of sight. They also produce rumbles called let's go rumbles, which are basically a way of indicating that they want the group to start moving with them in a particular direction. So you'll see an elephant standing at the periphery of the group, facing away from the group in the direction she wants to move, and she'll give these long, flat rumbles that indicate she wants to move off, and then often that will start a sort of discussion among multiple group members where they all produce these calls kind of in this sort of cadenced format. And we think that may be some form of discussion about where they want to move or whether they want to move off. Another very common context in which rumbles are produced is greeting, when two elephants who are bonded to each other approach one another to within touching distance. And then also in sexual contexts, elephants have particular rumbles that they make. So in the context of must, which is when male elephants, once they reach maturity, every year they go through this period where their testosterone increases in concentration, and they spend a lot of energy searching for mates and competing with other males. So when they're in this state, they produce a very unique and distinct type of rumble called a must rumble, which is very low in frequency. And it's very pulsated, so it sounds very different from other rumbles. And when female elephants are in estrus, right after they mate, they make these a particular type of rumble called an estrus rumble or a post-copulatory rumble repeatedly. So this usually happens after they mate with a male. Then they'll just call over and over and over again with these loud estrus rumbles, sort of advertising to other males that they're in estrus. Elephants also make rumbles in all sorts of contexts where they're excited socially. So after a female in the family mates, the other females in her family seem to get really excited about that, and they start calling and running around and acting exuberantly. So we call that mating pandemonium. And also when female elephants encounter a male in must, sometimes you get these chorused rumbles where they get all excited to meet this male who's in must. When elephants encounter a threat, like lions, for example, they also sometimes produce these very loud, noisy rumbles that almost sound a bit roar-like, and that's potentially to either warn other elephants about the threat or to intimidate the lions and let them know that they've been seen and threaten them away. If you look at the spectrogram, you can see that the must rumble has these, it's very pulsated. It's got like these bright bits here with this sort of quieter intervals in between, and you can hear that pulsation in the call. It's also lower in frequency than the contact rumble, although that's a little hard to see in this diagram. But anyway, so just a couple other contexts they make rumbles in. Caregiving is when a calf expresses distress in some way. The mother or other females in the group who take care of the calf will produce a rumble to comfort the calf. And also sometimes when they're just nursing a calf or touching a calf in an affiliative way, you'll hear these caregiving rumbles as well. For their part, calves produce rumbles to beg in addition to roars and cries and combination calls. And when they're upset about something like being denied access to nursing or being pushed or something like that, they make protest rumbles as well. And adults sometimes also make protest rumbles when they've been pushed or they've received aggression from another adult. And then finally, another common context in which you hear rumbles is when a calf is separated from its mother. So they'll usually start with rumbles, and then if they don't get reunited with the mother soon, then they'll progress to more frantic roars. So because rumbles are so low in frequency, it's been speculated that they could be really valuable for elephants to communicate with each other at long distances. So people have observed elephants seemingly coordinating their behavior over distances of up to 10 kilometers. And it's kind of a mystery how they managed to do this. So when it was first discovered that rumbles contained infrasonic components below the range of human hearing, people were really excited about this and thought that this might explain how elephants could communicate over such long distances. Because low frequency sounds generally tend to travel further than high frequency sounds. But experiments have shown that they actually probably don't travel as far as we think. So Karen McComb did some experiments in Amboseli where she played back rumbles and then recorded how far away the components that were necessary for elephants to recognize the caller were still visible in the spectrogram. They could still be detected. And she found that under really good propagation conditions on the savanna, the components of the call that elephants relied on to recognize the caller typically didn't persist more than about 1.5 kilometers. So that's still pretty far, but it's not nearly as far as the 10 kilometers that some people have speculated elephants might be able to communicate over. And under more average propagation conditions, the rumbles probably travel even less far than that. So one study on African forest elephants found that under more average propagation conditions in a rainforest environment, the rumbles typically were completely attenuated by about 800 meters. So another possible way in which rumbles could be used for long distance communication is that it turns out that when an elephant produces a rumble, this creates a seismic wave that travels through the ground as well. And elephants can feel these waves with their feet. And the seismic wave may travel further than the actual acoustic component of the call. So that may be a way that elephants can communicate over longer distances. But we still don't know exactly how much, if any, social information is conveyed by these seismic vibrations. There was one study that Caitlin O'Connell did in Namibia where she found that elephants in Namibia responded more to the seismic component of rumbles from their own population than from rumbles that were recorded in Amboseli. But it's still a little bit unclear whether they actually recognized the callers or whether it was something else about the stimuli that were played back that they were responding to. And as Lucy mentioned, elephants can recognize one another from the acoustic components of the rumbles. So rumbles are individually distinct. Every elephant has their own unique voice pattern in their rumbles. This is also true for roars, but to a lesser extent. So roars are individually distinct somewhat, but there's probably less potential to recognize individuals from roars than with rumbles. And some people have speculated that with combination calls, perhaps the rumble is tacked onto the roar in order to tell others who's making the roar, to make it easier to identify the caller. Elephants can discriminate not just that they can recognize their own family versus another family from their rumbles, but they can discriminate at least 3 different tiers of social affiliates based on rumbles. So they can discriminate the rumbles of their own family group and bond group, rumbles from distant social affiliates who are not members of their own bond group, but who they still interact with on occasion, and then also non-affiliates, elephants who they very rarely interact with. So that suggests that they can recognize at least 100 different individuals from their rumbles based on relatively limited interaction with some of those individuals. Now, just like trumpets and roars and barks and cries, rumbles contain information about the emotional state of the caller. So for example, rumbles increase in frequency when the elephant making the rumble is more emotionally aroused or when she's chronically stressed. And similarly, roars increase in duration and in noisiness with the degree of distress that the elephant is feeling. But rumbles are not just emotional calls. They also convey some information about entities in the elephant's environment. So for example, work by Joseph Soltis and Lucy King found that elephants produce different types of rumbles in response to different threats. So when elephants were played the sound of disturbed honeybees, they produced alarm rumbles in response. And they also produced alarm rumbles in response to the sound of the voices of Samburu warriors. But the rumbles that they produced in response to these 2 different threats were different. So the bee rumbles, in the bee rumbles, the first formant was increased in frequency relative to rumbles that were produced in response to white noise. But in the human rumbles, both the first formant and the second formant were elevated. And when the researchers played these rumbles back to the elephants, they found that they fled in response to both rumbles, but they only shook their heads in response to the bee rumbles. So in response to bee rumbles, they shook their heads more than they did in response to a control, but not in response to the human rumbles. And head shaking is a behavior that can be used to dislodge stinging bees. So that suggests that these rumbles may convey information about a specific type of threat. Although I think we still need more studies and more replication of this work to know for sure if these calls really refer to humans versus bees or whether they're just indicating different levels of urgency in the alarm call. And one thing that's very unique about elephants and their vocal communication is that they're among the few mammals that have a really sophisticated ability to learn new sounds. So learning sounds or vocal learning kind of has 2 different components. One is vocal production learning, which is the ability to learn to modify vocalizations based on experience of what you hear. And it's pretty rare in mammals. More mammals than we used to think have this ability to some limited degree, but elephants are actually able to imitate sounds from a completely different species. And we know this from captivity. So in one study, two captive African elephants imitated sounds that are completely unnatural for African Savannah elephants to make. So one of these elephants imitated the sounds of trucks that she heard near her enclosure, and another elephant imitated the squeak vocalizations that Asian elephants make because she was housed with Asian elephants. And African elephants normally never make these sounds in the wild. So because elephants are capable of mimicking sounds from other species or even non-animal sounds, we know that they have a really sophisticated ability to learn to produce new sounds. And they also have the capacity for vocal usage learning, which is the ability to modify the context in which existing sounds are made. So, for example, elephants in captivity can learn to produce their vocalizations on command. And what's interesting about this is that it seems to be easier for them to learn to produce rumbles on command than to learn to produce trumpets on command. And that's similar to the way in which it's a lot easier for us as humans to imitate the words that somebody else produces than it is for us to imitate the sound of spontaneous laughter. So when you laugh on command, it actually sounds different from when you laugh because you actually thought something was funny. And it's really hard to imitate the sound of spontaneous laughter when you actually thought something was funny. And that's because laughter is a quintessentially emotional vocalization. It's not really intentional. So it seems that there's a parallel here in elephants where the trumpets are these emotional calls that they have to really like try to make on command. But the rumbles seem to be these more intentional vocalizations that it's a lot easier for them to learn to produce on command, which suggests that they may be a more intentional form of communication as well. So we know that elephants are very good at learning new sounds, but we actually know very, very little about how they use this ability in the wild. Now, recently, my colleagues and I published a paper where we found a possible explanation for how elephants might use their vocal learning ability. So we found that elephants use distinct calls to address different members of their family group, essentially calling one another by name. And we found that we could predict who a call was addressed to just from the acoustic structure of the call, suggesting that some rumbles contain information that identifies the intended recipient of the call. And then when we played these calls back to the elephants, we found that they responded more strongly to a call that was originally addressed to them than to a call from the same caller that was originally addressed to someone else, which indicates that they can tell just by hearing a call if it was meant for them or if it was meant for a different member of the family. What was interesting is we found that these name-like features in rumbles were more likely to be used in certain contexts than others. So they were more likely to be used in the context of contact calling, where elephants are communicating with one another at a distance where they can't see each other, and in the context of caregiving rumbles, but not in the context of greeting rumbles. And the fact that caregiving rumbles were more likely to contain these name-like components than greeting rumbles suggests that perhaps this is how calves learn their names, because if adults don't seem to use names very much when communicating with other adults at close distance in greeting rumbles, but when they're communicating with calves, they do. And so it's possible that that's actually how the calves learn these names that others use to address them. But that's just speculation, and that's sort of will be the topic for future study. So then finally, in another paper that actually just came out yesterday, we found that the rumbles produced by elephants in different populations differ in structure. So in the Samburu elephant population in northern Kenya, elephant rumbles had higher and more variable frequencies than in the Amboseli population in southern Kenya. And in a previous study, we also found that the order in the preferred order in which elephants combine rumbles and roars into combination calls also differs between different populations of elephants. Now, how is vocal communication relevant to conservation? So there are a few different ways in which I think the vocal communication matters a lot for the conservation of elephants. So for one thing, if elephant rumbles differ between populations, it's possible that this leads to difficulties in communicating between different populations. And that has important management implications because managers often translocate elephants between different populations for various reasons, either to increase gene flow or to mitigate human-elephant conflict or for whatever other reason. And if there are issues in social integration because elephants in different populations use different means of communication, that could potentially complicate these translocation efforts. So I think we need to understand more about how elephants communicate and whether elephants from different populations can understand each other in order to do these translocations in a way that mitigates social disruption as much as possible. Also, work with African forest elephants especially has shown that monitoring elephant vocalizations through passive recordings, like you just put recorders out in the forest and just record all the elephant vocalizations, that can be really valuable for monitoring elephant populations, especially in habitats where it's difficult to observe the elephants. So for example, you can assess elephant population size and occupancy by counting vocalizations and seeing where vocalizations occur and where they don't. And potentially also this real-time acoustic monitoring could be used to mitigate human-elephant conflict by listening for elephant vocalizations and figuring out where the elephants are so that people can be given advance warning and don't, run into elephants on the road and end up getting hurt. There's also a lot of interesting or a lot of intriguing potential that hasn't really been fully realized yet to extract detailed demographic information from passive acoustic recordings of elephants. So it's been shown that elephant rumbles vary with the sex of the caller and the age of the caller, as well as the caller's physiological state. So if we could figure out a way to reliably predict these variables from passive recordings where we have no additional observations to pair with vocalizations, then we could potentially estimate things like the sex ratio and age structure of a population simply from passive acoustic recordings without having to actually observe the elephants in the field. Some people have also suggested that playing back vocalizations to the elephants could help mitigate human-elephant conflict. So for example, using calls of estrus females to lure males away from crops that they're raiding. I am not sure to what extent this will be valuable because I think the elephants would be likely to habituate to the calls over time, but it still could be a valuable tool within the larger toolbox of techniques for mitigating human-elephant conflict. And then finally, I think that vocal communication and behavior and cognition more generally has a lot of potential to help elephant conservation by changing hearts and minds. So people just can't help but be fascinated by animal behavior that seems similar to our own behavior, especially with charismatic animals like elephants. And I think that studies that show that elephants can keep track of their family members or can address one another by name or things like that really capture people's imagination. And this could be valuable for fundraising efforts for elephant conservation, as well as to improve attitudes toward elephants, toward facilitating human-elephant coexistence. So yeah, with that, I will pass it on to Michelle.
Thank you so much, Dr. Mickey. This was very insightful. Like, I had a question which I wanted to ask at the end, like, do elephants also, like, can they show their emotions through tone like the way humans do? But you have already answered it. Thank you so much.